Assalamu alaikum all of you. Welcome to my solution set for chapter 14, Permutations and Combinations from book 1. Question number 1 says, what is the total number of different permutations of all the letters in the word April? So we're trying to figure out the number of arrangements of all the letters in the word April. All 5 letters A, P, R, I, L are different from each other. So whenever you are arranging a certain number of distinct different objects in a straight line, the number of ways of doing that is n factorial. So because there are 5 letters over here, we'll simply do 5 factorial, and 5 factorial, I hope you all know, is 5 into 4 into 3 into 2 into 1, which becomes 120. So the answer is 120. That is option D. I hope this is clear. A very straightforward question to begin with. Question number 2. What is the total number of different permutations of all the letters in the word dollar? Okay, so the word dollar has 6 letters, as you can see, but you will also observe that 2 of the letters are the same. We have 2 L's here. So whenever you have certain letters being repeated, what you do is, with the number of arrangements of n items in a straight line where some of the items are repeated is always equal to n factorial divided by r factorial into p factorial into q factorial, etc., where r and p and q are the different numbers of letters that are being repeated. So in this case, we only have 2 letters being repeated, L and L. So we say n factorial, that's 6 factorial, divided by the 2 L's, so divide by 2 factorial. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Divided by 2 factorial is 2 into 1. And that should give you 360. So the number of arrangements of all the letters in the word dollar is going to be 360, option B. I hope this is clear to all of you. Question number 3. In how many ways can 5 teachers of mathematics be assigned to 3 sections of an introductory math course if no teacher is assigned to more than 1 section? So you can only assign 1 teacher to 1 section, and no teacher can get more than 1 section. So there are 2 ways of doing this question. The first method is what we call the hangman method. We figure out how many positions there are, and then we figure out how many options there are for each position. So we have section 1 and section 2 and section 3. What we need to do is we need to figure out the number of options available for each section. So for section 1, there are 5 teachers that are available. For section 2, there are 4 teachers that are available. 1 less, because remember, once you assigned a person to section 1, that person is not available anymore for the second section. So section 1, 5 options. Section 2, 4 options. And then section 3, 1 less than 4. That gives you 3 options. So you multiply these values together, 5 times 4 times 3, you should get 60 as your answer. So the total number of options that you can choose are 60. That's option C. Now you can also do this by the permutations formula, which is NPR, which is equal to n factorial divided by n minus r factorial. So in this case, you have 5 teachers, but you have to assign them to 3 sections only. So it's 5p3, which is 5 factorial, divided by 5 minus 3, which is 2 factorial. So you can write this as 5 into 4 into 3 into 2 into 1, divided by 2 into 1. Cancel out the 2 and the 1. You're left with 5 into 4 into 3. That gives you exactly 60 as well. So both options are valid. Both methods are completely valid, and you can use either method. I hope this is clear to all of you. Question number 4. From a group of 8 people, a team comprising a captain, a vice captain, and a coach is to be selected. The positions are identified clearly as captain, vice captain, and coach. How many such different teams can be constituted? Here again, we will assume that a person cannot be given more than 1 role. A captain cannot also be a vice captain or a coach. So each person is going to be different. So we can use the hangman method. Number of options available for each position. The positions are captain, vice captain, and coach. So for the captain, because there are 8 people, for the captain, there are 8 options available. And once you assigned 1 person to be the captain, that person is not available anymore. So for the vice captain, you have one less, which is 7 options. And once a person has been assigned as a vice captain, you can't use that person anymore. So for the coach, you have 6 options. So 8 times 7 times 6. Multiply them. 8 times 7 is 56. 56 into 6 is going to give you 336. So the answer must be option E. You could have also used the permutations formula, NPR, which is equal to n factorial over n minus r factorial. You had 8 people, and you were choosing 3 of those people and assigning them 3 different positions. So it can be written as 8p3, which is equal to 8 factorial, divided by 8 minus 3, which is 5 factorial. So this can be written, 8 factorial can be written as 8 into 7 into 6 into the rest is 5 factorial, divided by 5 factorial. So the 5 factorials cancel out, and you're left with 8 into 7 into 6, which gives you exactly 336, what we got in the first case as well. So both options are equally valid. You can use either method that you like. I hope this is clear to all of you. Question number 5. 3 lottery tickets are to be drawn at random from a bunch of 20 to award first, second, and third prizes. If no contestant can win more than one prize, so everybody gets one prize at maximum, what is the total number of ways in which these prizes can be awarded? So we have 3 prizes, the first prize, the second prize, and the third prize. And we're going to insert the number of options available for each position. So for the first prize, there are 20 people available. Once one person gets the first prize, that person cannot win the second or the third prize. So for the second prize, you will have one less, which is 19 options. And for the third prize, you will have again one less, which is 18 options. So you multiply 20 into 19 into 18, and that should give you the answer. Now, by the way, because 19 into 18 into 20 might be a very big number, look at the answer options. They're quite far away from each other. So you can approximate a bit. You know that 20 times 20 times 20 is equal to 8,000. So the correct answer has to be slightly less than 8,000. So if you look at the answer options, the only option that is slightly less than 8,000 is option D. So that must be the right answer, 6,840. I hope this is clear to all of you. You could have also used the permutation formula, again, like the previous cases. So we have 20 tickets, of which we are only choosing and arranging 3 tickets as the first prize, the second, and the third. So NPR is n factorial over n minus r factorial. 20p3 would be 20 factorial divided by 20 minus 3, which is 17 factorial. This can be written as 20 into 19 into 18 into 17 factorial divided by 17 factorial. You can eliminate the 17 factorial and the 17 factorial, and you get 20 into 19 into 18, which we know is 6,840. So the answer is going to be 6,840. And when you have such large multiplications, it's useful to use approximate values to get an idea, and also take a look at the answer options to get an idea of how much you can approximate. I hope this is clear to all of you. Question number 6. How many different 3-member teams can be chosen from a group of 8 people? So you're choosing a team of 3 people from 8 people. You're not arranging them, you're just choosing a team. So whenever you're choosing a team and the positions are not specified, that's a combinations problem, not a permutations problem. So you need to use the combinations formula, NCR, which is equal to n factorial divided by n minus r factorial multiplied by r factorial. So you have 8 people and you're choosing 3 of those people, so it's going to be 8c3, which is going to be 8 factorial divided by 8 minus 3, which is 5 factorial, times r factorial, that would be 3 factorial. So you can write this as 8 into 7 into 6 into 5 factorial divided by 5 factorial into 3 factorial. The 5 factorial and the 5 factorials cancels out. What you're left with is 8 into 7 into 6 divided by 3 factorial. 3 factorial is 6, because that's 3 into 2 into 1, that gives you 6. So you can cancel the 6 with the 6 and you get 8 times 7, which is 56. So the answer should be 56. I hope this is clear to all of you. If you wanted to do this like the permutation method, you would have made 3 dashes. And you have to remind yourself that this is not a permutation problem, but a combination problem. You are using the permutation technique, the hangman technique, but this is a combination problem. You start off in the way that you start off with the permutation question. You have 8 people, you have 3 positions to fill. So you say 8 times 7 times 6. But because this is a combinations problem, not a permutations problem, you need to then divide by 3 factorial. So 3 into 2 into 1. Just do this calculation and you will get the answer directly as 56. I hope this was clear. But if you find this method to be confusing, just go with the formula. Let's look at number 7. Number 7 is very similar to question number 6. So if you've done number 6 and you've seen the video, you understand both the techniques. I suggest you try it yourself. And if you have tried it and you still are not getting the right answer, here's the explanation. How many different 4-member teams can be chosen from a group of 10 people? So we have 10 people and we are choosing a team of 4 members. We are not arranging them, we're just selecting them. Then how many ways can we select 4 people from 10 people? That's a combination problem, not a permutation problem. So we'll use the NCR formula, which is n factorial over n minus r factorial times r factorial. So where your n is 10, you are choosing 4. So 10 C4, 10 combination 4. Some people say 10 choose 4. This is going to be 10 factorial divided by 10 minus 4, which is 6 factorial, times r, which is 4 factorial. When you expand this, you get this as 10 into 9 into 8 into 7 into 6 factorial divided by 6 factorial times 4 factorial. The 6 factorial and the 6 factorial cancels out. And what you're left with is 10 times 9 times 8 times 7 divided by 4 factorial is 4 times 3 times 2 times 1. Now we can simplify this. 4 times 2 is 8, so we can cancel out 4 into 2 with 8. We have 9 over 3, so 3 times 1, 3 times 3. So we get 10 into 3 into 7, that gives you 210. So there are 210 possible teams that you can choose, such that you have each team comprised of 4 members, chosen out of 10 people. Now, you can also do this by the permutations method, the hangman method. So let's try that out. There are 4 positions to fill. Okay. So you say 10 options for the first, 9 for the second, 8 for the third, and 7 for the fourth. But because the order does not matter, you're just choosing a team. You're not assigning them a specific position. You're just choosing a team. It's a combination problem. You need to remind yourself that it's a combination problem, not a permutation problem. Once you've done 10 into 9 into 8 into 7, you then need to divide this by 4 factorial, which is 4 and 3 and 2 and 1. And once you do that, you will get exactly the same answer as I got earlier, which is 210. So this is a pretty useful way of saving yourself time, and I suggest you practice this. I hope this is clear to all of you. So the answer to question number 7 is option D. Question number 8. 3 couples are to be seated in a straight line on 6 chairs. Now you know that each couple has 2 members. So you have 3 couples, that's 6 people. They are being seated in a straight line on 6 chairs. In how many ways can they be seated if each couple is to sit together? Okay, so let's do the hangman method for this. That's going to be our first technique. So we have the first seat, second seat, the third seat, the fourth, the fifth, and the sixth. Each of these positions represents a single seat, and only one person can sit on one seat. So for the first position, remember there are a total of 6 people. So there are 6 options for the first position. You can put anybody here without any restriction. On the second seat, however, you can only have the partner of the first person. The first person has obviously going to be having only one partner, so you just put 1 here. Then in the third seat, now you're free to put whoever you like. We've used 2 people so far out of 6 people, so we have 4 people left over. So in the third seat, I have 4 options. In the fourth seat, I can only put the partner of the person who I put in the third seat. So that's going to be 1 option only. So now we've used 4 people out of 6 people, so we have 2 people left. So in the fifth seat, I have 2 options. And the last seat, I have 1 option only. We multiply 6 into 1, into 4, into 1, into 2, into 1. And this gives you 48 as the answer. So the answer should be option D. I hope this is clear to all of you. I'm going to show this to you by another method. Let's look at method number 2. Question number 8. Let's do this by the second method. This question says 3 couples are to be seated in a straight line on 6 chairs. So we have 3 couples. Now obviously each couple has 2 members. Let's say the first couple is A and B. The second couple is C and D. The third couple is E and F. So we have 3 couples, a total of 6 people. Okay. In how many ways can they be seated if each couple is to sit together? So in a question like this, when you want to put certain people together, the first thing to do would be to arrange the couples first. Arrange the couples. So we have a total of 3 couples. So this is going to be 3 factorial. That's the arrangement of the 3 couples. Multiplied by arrange the elements within each couple, or the members of each couple. And then the first couple, you have 2 people. So that's going to be 2 factorial. The second couple has 2 people, so 2 factorial. And the third couple also has 2 people, so 2 factorial here as well. So 3 factorial is 6 times 2 factorial is 2 and 2 and 2. So what does that give us? 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. So the answer should be option D, which is 48. I hope this is clear to all of you. Question number 9. I have 3 books by Dickens, 2 by Alcott, and 2 by Salinger. In how many ways can these be arranged in a straight line on a shelf such that the books by each author are put together? Now the number of arrangements will be calculated by first arranging the authors and then multiplying it by the arrangements of the books within each author. So we have 3 books by Dickens. Let's assume those are called A, B, and C. That's the first set. 2 by Alcott, let's call them D and E. And 2 by Salinger, let's call them F and G. So the first thing to do is to arrange the authors. Those are 3 authors, so 3 factorial. Times arrange the books within each author. The first author has 3 books, so that's going to be 3 factorial. The second author has 2 books, so 2 factorial. And the third one has 2 books as well, so 2 factorial. So 3 factorial is 6, times 3 factorial is 6, times 2 factorial is 2, and times 2. So 6 times 6 times 2 times 2 should give you 144. So there are going to be 144 arrangements in such a way that the books by the same author are always together. I hope this is clear to all of you. Question number 10. There are 4 Pakistanis and 3 Indians who are to be arranged in a straight line. In how many ways can this be achieved if each nationality is to stand together? So we have 4 Pakistanis. Let's call them A, B, C, D. And 3 Indians. Let's call them E, F, and G. And you want to arrange them in a straight line in such a way that the members of each nationality are always together. So to do that would require us to first arrange the nationalities. So there are only 2 nationalities, Pakistanis and Indians, so that's 2 factorial. Multiplied by arrange the elements within each group. So the first group, Pakistanis, has 4 members, so 4 factorial. And the second group, Indians, have 3 members, so 3 factorial. So we get 2 factorial, which is 2, times 4 factorial, which is 24, times 3 factorial, which is 6. So 6 times 2 is 12. 12 into 24 would give you 288. So the answer has to be 288, which is option B. I hope this is clear to all of you. Question number 11. In how many ways can a group of 2 men and 3 women be chosen from a group of 4 men and 5 women? So from 4 men, we are choosing 2, and from 5 women, we're choosing 3, right? So choose 2 men from 4 men and 3 women from 5 women. And this is a selection problem. It's a combination problem, not a permutation problem. So we'll use NCR here. So for the 2 men to be chosen from 4, it's going to be 4C2. And for the 3 women to be chosen from 5, it's going to be 5C3. So 4C2 is going to be equal to 4 times 3 divided by 2 times 1. And 5C3 would be 5 times 4 times 3 divided by 3 times 2 times 1. So this will cancel out and give us 12 upon 2, which is 6. And this will cancel out and give you 10. So 6 times 10 gives you 60. So the answer should be option B, which is 60. I hope this is clear to all of you. Question number 12. 3 boys and 5 girls are to form a line. What is the number of ways in which they can be arranged if the first is a boy and the last person is a girl? There are a total of 8 people, 3 boys and 5 girls. That's a total of 8 people, 3 boys and 5 girls. So let's create 8 positions. And we're going to insert number of options available for each position. The first is supposed to be a boy. So we have 3 options for the first position. The last is supposed to be a girl. So the last person, the 8th person, is a girl. There are 5 girls to choose from. So there are 5 options here. And once these 2 positions have been filled, the remaining positions in the middle, there are 6 positions in the middle. They can be filled by any of the remaining 6 people, because out of 8 people, you've used 1 person for the boy and 1 person for the girl. So out of 8 people, you've chosen 2 already. What you're left with are 6 people. So you have 6 options for the second position, 5 for the third, 4 for the fourth, 3 for the fifth, 2 for the sixth, and 1 for the seventh. So it's 3 multiplied by 6 times 5 times 4 times 3 times 2 times 1 times 5. So this is basically 3 times 6 factorial times 5. Now, if you remember, 6 factorial is 720. You have 3 into 720 into 5. And let's do a quick multiplication. 720 times 3 is going to be 2160. 2160 times 5. Multiplying by 5 is like multiplying by 10 and then dividing by 2. So 21,600 divided by 2 should be equal to 10,800. So the answer should be option B. This is the correct answer. I hope this is clear to all of you. Question number 13. 5 boys are to be arranged in a straight line in such a way that the shortest boy is in the middle and the 2 tallest boys are at the ends. In how many different ways can they be arranged? So let's create these 5 positions. And the requirement is that in the middle, in the third position, you must have the shortest boy, right? Now let's assume that these people are A, B, C, D, and E. And let's say that this is your shortest person, and that these 2 are your 2 tall people, okay, your 2 tallest people, right? So the question said that in the middle position, you need to have the shortest person. So there is only one option here. Whoever is the shortest person, that person needs to come here. Nobody else can come here. So there's only one option for the middle position. Now, as far as the first and the last positions are concerned, you need to put the 2 tallest boys at the ends. The 2 tallest boys are supposed to come at the ends. The word ends here means the first and the last position. Now, it doesn't say that the tallest person has to be in the first position and the second tallest in the last. They could interchange as well. So you see these 2 people, D and E, that we assumed were the 2 tallest people in that group. So you have 2 options for the first position. And once one of them has been used here, the other person has to come at the end. That's one option for the last position. So from 5 positions and from 5 people, we've used 3 people already. So that leaves us with 2 people. So for the second position, I have 2 options. And for the last position, I have 1. And when you multiply them, 2 into 2 into 1 into 1 into 1, that's going to give you only 4 options or 4 arrangements. So the answer is going to be option E, 4. I hope this is clear to all of you. Question number 14. A team of 5 members is to be chosen from 7 boys and 4 girls. So we have 7 boys and we have 4 girls, and from these 11 people, we are choosing 5 people. Okay. Find the number of ways in which this can be done if the team has exactly 3 boys. So if you're choosing 5 people and from those 5 people, 3 are supposed to be boys, that means that the other 2 must be girls. So the 5 people that you're choosing, it needs to have 3 boys, and therefore we need to have 2 girls. So basically my task is to make sure that from the 7 boys, I choose 3 boys, and from the 4 girls, I choose 2 girls. So 3 boys from 7 boys and 2 girls from 4 girls. And this is a selection problem, so it's a combination problem. It's not an arrangement problem. So this is going to use NCR. Okay, so from 7 boys, we are choosing 3, so that's 7C3. And from 4 girls, we are choosing 2, so it's going to be 4C2. So let's do the calculation. 7C3 is going to be 7 times 6 times 5 over 3 times 2 times 1. This simplifies to 35. And 4C2 is going to be 4 times 3 divided by 2 times 1. That's going to be 12 over 2, which is 6. You've got to multiply these numbers together. 35 times 6 will give you 210. So the total number of combinations possible is 210. Option B is the right answer. I hope this was clear to all of you. Question number 15. In how many ways can 6 people be seated around a round table? So you're not putting them in a straight line, you're putting them in a circle, and the number of arrangements of n distinct objects in a circle is always equal to n minus 1 factorial. So if there are 6 people, then the number of arrangements is going to be 6 minus 1 factorial, which will be equal to 5 factorial, and 5 factorial is 120. So the answer should be option D. A very straightforward question. Just remember the formula that for circular arrangement, it's n minus 1 factorial. I hope this is clear. Question number 16. This question is about creating numbers from different digits. It says how many 3-digit numbers can be formed from the digits 0, 1, 2, 3, 4, 5 if each digit can be used only once. So repetition is not allowed. We have 6 digits available that we can use. We have to create numbers that contain 3 digits. So there are 3 positions to fill: the hundreds, the tens, and the units. Remember, when you're creating numbers, you should never use 0 in the first position, because if you're trying to create a 3-digit number, you start with a 0, it'll become a 2-digit number. So you can never start from a 0. Make sure that 0 doesn't appear in the first position. So for the first position, how many options do I have? Well, I have 1 and 2 and 3 and 4 and 5. I have these 5 options apart from 0. So that's 5 options for the hundreds position. Now I go to the tens position. Now remember, we had a total of 6 options, including 0. 0 is allowed everywhere else except the first position. So we had a total of 6 options, but since repetition is not allowed and we've already used 1 digit in the first position, that will leave us with 5 options in the second position. And then you come to the last position. We had a total of 6 options. We've used 2 now, 1 in the hundreds, 1 in the tens. So out of 6, we've used 2. So that leaves us with 4 options in the last position. So you multiply 5 into 5 into 4, and that gives us exactly 100. So we can create 100 3-digit numbers using the digits 0, 1, 2, 3, 4, 5. such that no digit is used more than once. I hope this is clear to all of you. The answer should be option E. Question number 17. This question is also about creating numbers. It says how many three-digit odd numbers, so you're creating odd numbers, okay? This is an important part. You're creating three-digit odd numbers can be formed from the digits 0, 1, 2, 3, 4, 5, 6, if no digit can be used more than once. So repetition of a digit is not allowed. So you had a total of 7 options, 7 digits that you can use, but the numbers that you're supposed to be creating are supposed to be three-digit odd numbers. Now remember, as in the previous question, you cannot use 0 in the first position, because using a 0 in the first position will change the number from a 3-digit number to a 2-digit number. So we cannot use 0 in the first position. And also remember that because we're trying to create odd numbers, by definition, an odd number is any number whose last digit is odd. The other digits don't matter. They could be even, they could be odd, it does not matter. But to create an odd number, the only requirement is that the last digit, the units digit, must be odd. Okay, so we need to make sure that the last digit is odd. So we're going to start from the last position. We'll start here. And why am I going to start here? Because there is greater restriction on the last position. In the first position, the only restriction was that you can't use a 0. But in the last position, I need to make sure that I only use an odd digit. So how many odd options do I have from the list of digits that I've been given? Well, I can use a 1, I can use a 3, or I can use a 5. That's it. That's all that I can use. So there are 3 options here. I've put 3 here. Now I go to the first position. So for the hundreds position, we had a total of 7 options. From those 7 options, we've already used one option in the last position. Whatever option we used, we've used that. So one option is gone. That leaves you with 6. But in those 6 options, we still have 0. And remember, we're not allowed to use 0 in the first position. So that just leaves us with 5 options here. Now you come to the middle position, the 10th position. That's the only one that's left out to fill. There are no restrictions here. The only restriction is you cannot use the digits that you've used already. We've used 1 digit for the units position. We've used 1 digit for the hundreds position. So out of a total of 7, we've used 2 digits. That leaves us with 5 digits in the middle position. So you multiply that, 5 into 5 into 3, and that gives you 75. So we can create 75 3-digit numbers such that they don't begin with a 0. They can't, and they must end in an odd digit. So the answer is 75. That's option A. I hope this is clear to all of you. Question number 18. 3 boys and 4 girls are to form a line. What is the number of ways in which they can be arranged if no 2 girls stand next to each other? So what needs to happen is that the girls need to be separated from each other. When it says no 2 girls stand next to each other, what this means is that you must make sure that the girls are separated from each other. Now you have 3 boys and you have 4 girls. There are no restrictions on the boys, but the girls, they need to be separated from each other. So the way to do this is to break this into 3 steps. Step 1 is to arrange the people who can stand next to each other. Those are the boys. So what I'm going to do is I'm going to create positions for the boys. I'm going to say 1, 2, and 3. I'm going to put a boy here, and a boy here. Remember, there are 3 boys, so I need 3 positions for the boys. Now step 2 is to create positions around the elements arranged in step 1. So we're going to create positions around the elements. That's position 1, position 2, position 3, and position 4. These are the created positions that I can use to arrange the girls. And step 3 is to use the created positions to arrange the items that need to be separated from each other. So the girls need to be separated from each other. So there are 4 girls. So I'm going to put a girl here, a girl here, and a girl here. And the important part is that because there are 4 positions and there are only 4 girls, exactly 4 girls rather, then the number of arrangements is going to be pretty easy. That's going to be 4 and 3 and 2 and 1. And for the boys that we had arranged earlier, the number of arrangements would be 3 into 2 into 1. So when you multiply these numbers, you should be able to get your answer. So it's going to be 4 into 3 into 3 into 2 into 2 into 1 into 1. 4 times 3 is 12. 12 3 is 36. 36 times 2 is 72, and times 2 is 144. So the answer should be 144. This is the number of ways you can arrange the girls and the boys in such a way that the girls are all separated from each other. I hope this is clear to all of you. So the answer to number 18 is option A. Question number 19. 6 teams are to play against each other once in a tournament. How many matches will be played? So remember that every game involves 2 teams. So whenever you have n teams, then the number of matches that will be played between those n teams is always equal to nc2. It's always nc2, never nc3, never nc4, never nc5. It's always nc2 because each game involves 2 teams. So there are 6 teams here. So n is 6. We're going to write 6c2. That should be 6 into 5 divided by 2 into 1. That gives you 15 games. So the total number of games that will be played is going to be 15, which is option E. I hope this is clear to all of you. Question number 20. 8 teams are to play against each other 5 times. Not once, 5 times. How many matches will be played? Quite a few. Well, the first step to do is to calculate how many matches would be played if they played against each other once and not 5 times. You always begin from there. And remember, each game involves 2 teams. So the number of games that will be played between n teams is nc2. So that will be, in this case, there are 8 teams. So we'll do 8c2, which is going to be 8 times 7 divided by 2, which is going to be 28 games. So the number of games played will be 28, assuming that they play against each other exactly once. However, in this particular tournament, each team is supposed to play every other team 5 times, not once. So once you found the answer is 28, that's the number of games that will be played if they played against each other exactly once. All that you need to do now is multiply this with 5. So just do 28 times 5, and that will give you 140. So the total number of games played would be 140, option D. I hope this is clear to all of you. Question number 21. A restaurant menu lists 3 soups, 10 meat dishes, 3 beverages, and 5 desserts. In how many ways can a meal be ordered if each component is selected once? So you're going to select 1 soup, 1 meat dish, 1 beverage, and 1 dessert. And we have 3 options for the soup, 10 for the meat dishes, 3 for the beverages, and 5 for the desserts. But since we're only selecting them, we're not really arranging them. This is a combination problem. We just need to do separate calculations for each of these components. So it's going to be 3C1 for the soups, 10C1 for the meat dishes, 3C1 for the beverages, and 5C1 for the desserts. So 3C1 is 3, 10C1 is 10, 3C1 is 3, and 5C1 is 5. So when you multiply them, it's going to be 450 possible combinations. So the answer should be option E. I hope this is clear to all of you. Question number 22. An automobile manufacturer offers 6 different models with a choice of 10 different exterior colors and 7 different interior colors. How many different cars does it offer? In other words, how many cars can you order, or how many different combinations of cars can you order? So you're going to choose 1 model from 6 available, 1 color from the 10 available, and 1 interior color from the 7 available. So you have to choose 1 of each. So it's basically a combinations problem. 6C1 into 10C1 into 7C1. This is going to be 6 times 10 times 7, and that should give you exactly 420. So we can order 420 different cars from this particular manufacturer. So the answer should be option E. I hope this is clear to all of you. Question number 23. How many different arrangements of the letters in the word pepper are possible? Now we have 6 letters, but it's visible that some of these letters are repeating. For example, P occurs 3 times, so P occurs thrice, and E also occurs twice, so E occurs twice. So we need to account for that repetition as well. Remember, we've discussed this concept before. The number of arrangements of n items in a straight line where some of the items are repeated is always equal to n factorial, where n is the total number of items, divided by r factorial into p factorial into q factorial, to remove the places where these letters are repeated. So it's going to start off with n factorial. So there are 6 letters. So let's begin with that. 6 factorial divided by, there are 3 p's, so 3 factorial, and 2 e's, so 2 factorial. Okay, and then you just do the calculation. So 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 times 2 times 1. Eliminate whatever you can, make your job simple. So it becomes 6 times 5 times 2, which is equal to 60. So there are 60 arrangements of the letters in the word pepper. Option delta is the right answer. 24. There are 3 roads from PECHS to Southern, and there are 5 roads from Southern to Clifton. Faraz is driving from PECHS to Clifton, through Southern, and back to PECHS through Southern again. He goes from PECHS to Southern, and Southern to Clifton, Clifton back to Southern, and from Southern to PECHS back again. How many possible routes can he take if he does not use any road twice? So repetition of a route is not allowed. So let's make the hangman positions here. So he goes from PECHS to Southern. Remember, there are 3 roads from PECHS to Southern, so 3 options here. And from Southern to Clifton, there are 5 roads available, so put 5 here. Then when he goes back from Clifton to Southern, he will have 4 options available, because whatever route he used while going from Southern to Clifton, coming back, he cannot use that road again. So from Southern to Clifton, he had 5 options. So from Clifton back to Southern, we'll have 1 less, we'll have 4 options. And similarly, from PECHS to Southern, he had 3 options. So on the way back, he won't be able to use that same route, so he will have 2 options here. And that's it. You just multiply these numbers and you should get your answer. So 3 into 5 is 15. 15 times 4 is 60. 60 into 2 is 120. So the answer is he has a choice of 120 possible routes in such a way that he does not use any specific routes that he used before. I hope this is clear to all of you. Question number 25. A menu offers a choice of 5 soups, 8 main courses, 4 desserts, 3 beverages. How many different meals comprising of 2 soups, 1 main course, 3 desserts, and 2 beverages can be made? So this is a menu choice question again. So we have to basically choose 2 soups from 5, 1 main course from 8, 3 desserts from 4, and 2 beverages from 3. Again, we're not arranging these, we're just selecting them, which means it's a combinations problem, not a permutations one. So basically we'll use NCR. So for the soups, it's going to be 5C2. For the main course, it's going to be 8C1. For the desserts, it's going to be 4C3. And for the beverages, it's going to be 3C2. So 5C2 is basically 5 into 4 divided by 2 into 1. That gives you 20 over 2, which is equal to 10. 8C1 is 8. 4C3 is the same as 4C1. So it's going to be equal to 4. I hope you remember that 4C3 and 4C1 are going to be the exact same values. And 3C2 is the same as 3C1. So that's going to be equal to 3. So multiply these values. 10 into 8 into 4 into 3. 8 times 4 is 32. 32 times 3 is 96. 96 times 10 gives you 960. So the total number of combinations possible is 960. I hope this is clear to all of you. The answer is option E. Question number 26. A reading list for a humanities course consists of 10 books, of which 4 are biographies and the rest are novels. Each student is required to read a selection of 4 books from the list. So there are 10 books, 4 are biographies, 6 are novels, and the students are required to read 4 of those 10 books. And the question says, including 2 or more biographies. So the books that you choose, they should have at least 2 biographies, which means you can have 2 biographies, or you can have 3 biographies. You can also make all 4 biographies. Okay. How many selections of 4 books satisfy the requirement? Right. So the way to solve this question is very simple. What we do is we write down all the possible options that we can have for selecting these books. So remember, there are 4 biographies and 6 novels. So what you can do is when you're selecting, you have to select 4 books from the options that you have. So it's possible you make them all biographies, 4 and 0 novels. It's possible that you make them 3 biographies and 1 novel. You can also do 2 biographies and 2 novels. What is also possible but not acceptable is that you choose 1 biography and 3 novels. And it's also possible but not acceptable that you choose 0 biographies and 4 novels. Now this one is not acceptable, so we're going to ignore this. This is not acceptable. Remember, the question said that you need to have 2 or more biographies, and this is also not acceptable. So the first 3 options are acceptable, the last 2 are not acceptable, so we won't bother about those. So the number of ways of choosing 4 biographies from 4 is 4C4, obviously, and you're choosing 0 novels from 6, so that's 6C0. The 4C4 is 1, 6C0 is also 1, so that gives you 1. Now you could also choose 3 biographies and 1 novel, so that will be 4C3 times 6C1. 4C3 is 4 and 6C1 is 6, and 4 times 6 gives you 24. And then you can also choose 2 biographies and 2 novels. So 4C2 for the biographies and 6C2 for the 2 novels. So 4C2 is going to be 4 times 3, 12, divided by 2 is 6. And 6C2 would be 6 times 5, which is 30 upon 2 will give you 15. 15 times 6 is 90. So each of these is an acceptable outcome. So what you do is you need to just add them up. You will not multiply them, you will add them, because this is an or condition. Either 4 biographies and 0 novels, or 3 biographies and 1 novel, or 2 biographies and 2 novels. You add them up, so you get 90 and 24 and 1. So that should give you 90 and 25, which is going to be 115. So the total number of possible outcomes, acceptable outcomes, is 115. That is option B. That should be the right answer. I hope this is clear to all of you. And that, my friends, is the end of chapter 14, permutations and combinations. I hope all the questions are clear to you. If you have any issues, feel free to let me know.